Hello, everybody. Welcome to the knowledge sharing session on, it was sold as railway-oriented programming, but what I'm going to use it for is sort of a high-level overview of a lot of the patterns that we're using for the remote development workspaces feature. And because a lot of these are interrelated and build on each other, so we may do future sessions to dig into some of these more. Also, I didn't do much prep, and I was sick yesterday, so most of this is going to be off the cuff. Feel free to jump in with any questions. And no slides. I just have we have some documentation, and that's mostly what I'll go through. To set the background of this. So about a little over around a year and a half ago, we started a remote development workspaces project, which was completely greenfield. And soon after I got merged, I wanted to take the opportunity to explore some new patterns that were different than most Rails or Ruby that you would see, but that I'd seen a lot of benefit in other places. And not just patterns for like the pattern's sake or, you know, a language nerd. Like my experience with functional programming and type safety is, you know, I had done pure Ruby and pure JavaScript for years. And for a brief period, I did some Kotlin and I did some Elm, which is a pure functional language. And that really showed me the power of these patterns for the testing pyramid, you know, the whole middle layer that, you know, is everything glued together right in the right type and the right arity and not null. You can get away with not having to write a lot of that tests for that stuff. And then when I went back to writing pure Ruby and vanilla JavaScript, I was like, oh, undefined is not a function, or null pointer exception, all that Java. It's like, I have to write all these tests to catch all of my own stupid mistakes. And so that was my personal experience with the power of functional programming and type safety. So I wanted to try to see how much of that can we get in modern Ruby, in Ruby 3. And turns out you can get a pretty fair amount even without doing, you know, RBS, which is Ruby's new type system. So that's where it is. I'll go ahead and start sharing my screen and just talk through. If I'm completely rambling and don't make any sense, please stop me. Share screen. Okay. Let me get your faces back up. There you are. Okay. So just as a little bit of context, and you don't have to raise your hand, but who's ever done functional programming? Okay. Who knows what a pure function is? So, spoiler, I have it up here. Pure function is a block of code that always returns the same results of the same arguments. So like no start effects, its inputs and its outputs. And then higher order function, that's another key concept here. And all that is when you take a function, like a reference to a function, and pass it as an argument to another function or method or whatever. And then that's all it is. And in Ruby, like everything's an object, including methods themselves. So that's what a higher order function looks like in Ruby. You could just pass a reference to a method object to another method. So big picture. So I'm going to narrow down, set the stage first before I actually get into the railway-oriented programming with just some basics of our architecture. So one of the concepts, like this is a greenfield project, so we really wanted to try to lean into good practices and especially be aligned with the modular monolith approach, where the domain code for a specific domain, in this case, remote development workspaces, is really clearly defined, loosely coupled to other domains, highly cohesive. It all lives in one place, or at least under the same namespace everywhere. And this is sort of what the architecture looks like. So the client comes in, here's the Rails monolith, and you know, it comes in through the routing and controlling, rack, all of the standard Rails stuff. And then we either have the Grape REST API or the GraphQL API, resolvers and mutations. And then we have the services layer, which, like, spoiler, it almost contains nothing, and we're thinking of getting rid of it in this architecture. And then all of the creamy middle here, all of our domain logic, almost all of it lives here. Nothing in the controllers, like all super thin layers here, only what needs to be here. A little bit of the business logic lives in our active record models, like things that make sense, the validations, the scopes, a little bit of helpers that, massage properties of the model and present them, but all of the actual business logic, everything that the domain does, lives here. Any questions on this so far? Okay, so and this is based on the modular monolith, but the hexagonal design, like, not strictly, but this is sort of how you can think of it. And there's a link in the README. This README is right at the root of this domain layer in EE lib remote development. And that was a great idea from Gregor's that he gave. He's like, just document all this, like, in the code itself, in a README that lives right next to the code, which is a great idea. So the concept here, this is a good article that's linked in that README, is you've just got these layers, and with the business logic living at the middle of it. So some more concepts that are important before building up to the railway-oriented programming stuff. So just wrapping that up, this talks a little bit about, like, why are we even doing this? It comes down to coupling and cohesion. Like, the domain layer is very cohesive. It does our domain logic, doesn't do anything else. It's very loosely coupled. Like, all it depends on are some other domain services, like maybe the GitLab agent for Kubernetes, interactive record models. And so that's it. You can see that we have this sort of settings module that lives outside that ties together stuff from the instance level. Like, we can get settings from like 5 different places. We inject that in. Even our business logic is not even directly coupled to that stuff. It's very loosely coupled.
I have a question, Chad, about that. What about things like feature flags? Because you mentioned settings. Like, I feel like those are concepts that kind of find their way into all these different, like, everywhere, basically, in the monolith. So are you careful not to include those at these various outer layers as well?
Feature flags we're not that great on. Like, feature flags and maybe some observability stuff, yeah, we will just call those. But, like, we could, and in many cases we do, like, we could get the state of a flag and pass it, inject it down into here. So that avoids at least your direct coupling to, like, Rails or the feature flag constants, which gives you a lot of nice things in terms of the modularity, but, like, you can also use fast spec helper. Any class that is not directly coupled to Rails, you can use fast spec helper, and it runs in like 200 milliseconds instead of 45 seconds, which we really try to lean into that. And a big key to that is, like, yes, these dependencies on the monolith or Rails itself, we inject in, and then you could just mock them in the business logic.
Okay. And is the same true for, like, authorization checks and current user? Those are the other concepts that love to just be everywhere.
So, like, we do some auth checks where I think the direction we're being led is to just try to put as much of those in declarative policies as possible and not worry about them at the lower levels. Like, why duplicate yourself? And then as far as user, like, yes, we use user, but that's this dependency here. User is an active record model. Like, you have to depend on your persistence layer, and we call that out. So the unfortunate class that, like, has to actually work with user, yes, that can't be a fast spec helper, and you're waiting, 15 seconds if Spring is loaded, 45 seconds if it's not, to run it. Thanks for your question. So type safety. Here's the great quote from Paul Slaughter. We try to be as type safe as profitable. And that's that key, one of the keys to, in a strongly typed compiled language, like an Elm or Kotlin or anything like that, it won't even compile unless you have all that middle layer of the pyramid. You don't need that middle layer of the testing pyramid because your program won't even compile and run. And we sort of try to lean into that by doing type safe as profitable. So we have yard annotations, and that's just a it's a standard for declaring the types of your parameters and return values. I think I just saw a proposal for Rubocop to try to say that we should do this for all of the types. I think Doug Stoll just put that in. Union types, not going to go deep into this, but it's like message is a good example of this. I think if I can go into the code, we'll look. Oops. Here's an example of our message union type. So it's just a module, and it's got all of these classes in here. And spoiler alert, as you can see, like we can type check. We can do a case statement on this union type. So that's sort of what we're talking about here, union types. Pattern matching, Ruby 3 has some nice pattern matching. Like you can have a case statement that matches on types of things or structures of hashes or nested arrays, like data structures, and say, okay, if the thing in my case statement looks like this, then I'm going to do this. So modern Ruby is pretty cool. This is something that we lean heavily on, right? Word assignment with pattern matching and with types. And this is a really cool thing that you can get some type safety in Ruby 3 without actually using RBS. And so say you have a hash, right? Y is the key, the value is 1. This syntax here is you can say, okay, given that hash, I'm going to write word assignment, and this key must be an integer. And if it is, then I'm going to destructure that out and put the value of it into this variable here. So that's 1. So if Y happened to not be an integer type, like here it's a string, it will blow up with this kind of a cryptic, it's not cryptic, but it's not the greatest error message, but no pattern matching error. But this is a type safety in Ruby, right? It's saying, hey, the thing I just structured out of this has to be of this type. So we do this a lot of places in the pattern with, especially with railway-oriented programming. We're like, okay, we're getting this hash passed along. I'm going to destructure out just what I need cohesively, type check it, and use it. So you can also do this without a type. Null safety. I just had a suggestion on the latest MR to this that we should just make everybody use hash.fetch everywhere. I've done this for a long time in Ruby, even before this stuff was supported, just to say, okay, blow up if whatever I'm trying to fetch out of this hash is null. Blow up early and fast, because that's when you want to blow up instead of this. So, and I know Paul and I went back and forth on this section here. So if you look at this and if you kind of squint at it in the right way, like if you have really good tests at multiple layers of the pyramid that are executing this stuff, this is sort of like a type safe compiler, even though Ruby is an interpreted, non-compiled, non-type safe language. If you're doing every place you're using your parameters, you're type checking them, and then you're ensuring that you're executing that code through your tests, it's sort of like a compiler. But remember, it's only as good as your tests. Fair enough, Paul? Is that a fair representation?
I think it's a good disclaimer.
Okay. So functional patterns. You can do functional programming in Ruby. But we, again, just as much as profitable and like not crazy stuff that is just for the sake of doing it. For example, currying, which is make everybody's head explode. That would not be a good thing to try, even though Ruby supports it. So we don't do anything like that. But we do lean on functional concepts like immutable state wherever possible. One of the things we do is use to enforce this immutability is use pure functions. So like we saw before, no side effects returns the same thing. The way we've implemented that in our code is by singleton methods. So even though there's a singleton class that is like the singleton pattern, that's not what we're talking about. We're talking about like a class method, which in Ruby is actually called a singleton method. And if you look here, like everything in here and all of these other classes, we have no instance methods, we have no instance variables, which means that you're not allowed to have state. You're no instance, like you could have a class level instance method, or you could have a class method, but you don't. And like sometimes we do class instance methods like for memoization, but we don't do that here. Like everything, all of these steps are a pure function, no state, which is good because state is the source of bugs. Like when you test something like, okay, I have to test for every possible state. If it's a pure function, it's like, I know it's always going to behave the same way given the input. So higher order functions, we talked about that. It's just passing in a method argument. And what that looks like is this. We're just passing a method as a parameter. That's a higher order function in Ruby. And I'll get into the row-oriented programming, the result, and what all of this means, but we're just covering the building blocks. Concurrency and parallelism, like by using immutable state, by using pure functions, things like this, it's inherently, more concurrent and parallelism. Like if we ever wanted to run this in multiple threads for whatever reason, or the reconciliation loop, which is sort of the core of that, we can parallelize that fine. It's all pure functions. There's no state. And the error handling based on row-oriented programming. So like, do we still use OO? Yeah, of course. Like we have value objects. We pass some value objects around, like message is a good example of that. We just saw that. Right, these are just little bundles of data that does have an instance method. It does have some state, but it's just encapsulating this error message. And we pass it around to our pure functions. Mixins inheritance, like we do use mixins, which is really a form of it's multiple inheritance. Mixins in Ruby, concerns, whatever you want to call them, are basically just a form of multiple inheritance. And we do use that because it's a useful pattern. But we don't currently use superclasses or anything like that, because in my mind, like single inheritance versus multiple inheritance, like, okay, single inheritance, you're just locking yourself into only having one thing you can inherit from. Whereas if you use modules and mixins, you can have as many as you want. So that's the choice we make. Inversion of control. In the last edit of this, we went back and forth a lot, like not dependency injection, because that sort of implies an OO pattern and you have interfaces and maybe a framework to wire everything together. That's not what we're doing. Like just the general concept, like we talked about up here, is yeah, the service layer like gets everything that these pure functions need and then injects them into it. So then the coupling to the rest of the monolith and other things mostly ideally is all here. And then these things don't have to be coupled. Therefore, they're easier to test, debug, etc. Any questions on any of that so far? And
yeah, I'm gonna we could talk about the inheritance and mixins. And typically there's a guiding principle of preferring composition over inheritance. I was wondering if there's any practices of that are happening in the current like remote development code base, or I guess if we're not using classes, we wouldn't like compose classes per se, like with decorators, but maybe we're doing that with functions in a certain way.
So like, here's a good example. It's like, yes, you could use composition, but like it's leaning into Ruby idioms and like, would that make the code more complicated? So this message support is a perfect example. Like we have this generate error response from message, which you can see here, we extend this, which is it's a mix-in, and that gives us this method. And this method is basically just taking the contents of this message, turning it into a human readable string, which bubbles all the way up and is literally displayed as a sentence on the view UI or the GraphQL error. But like if we wanted to say, no, we're not going to do any of this crazy OO stuff. It's got to be a pure function everywhere. Like we'd have to inject this message support module from somewhere else. And like in Haskell, for example, or like in Elm, it's like everything has to come from the very beginning because everything must be a pure function. And that makes some things, a lot of things a lot harder, like mocking, for example, and stuff like that. So this is where multiple inheritance / mixin is just, it's easier, it's simple, everybody understands, it's no reason not to use it. Does that answer your question?
Yeah, I think so. I think there's just Rubyisms that's like, because it's always find it so, I find myself wrestling with the language when I can't just import a function. Like I just want to have a dependency on a function. I don't want to like the function to become a part of me. But I know that that's just Ruby is just like that, where it's like, yeah, if you want helpers, whatever, you include them and they're in the scope now. But yeah, that makes sense.
Yeah, I mean, we're still trying to do idiomatic Ruby, and we're still trying to lean into standard Ruby Rails patterns and mix-ins and stuff, but use these functional patterns where they're profitable.
Yeah, makes sense.
I have like a kind of related question about the concerns versus inheritance. I actually was just dealing with a bug last night that was in a module. It's hiding there for me because it was in a class that includes like 7 modules and it has inheritance, and you're like, where is this? What is the behavior of this class? I have to go to like 10 files to figure it out. So do you find with this style of programming, is there, and I think the reason that happens, by the way, is because like modules just end up being the junk drawer, right? Like you're like, I don't know where to put this. I'll throw it in a module, call it like blah helper, and then include it in 10 things. Do you find that this format of writing Ruby makes that less of a problem, or you're just really disciplined? Like I was impressed that your module only had 1 method. I feel like, is that the result of this pattern, or are you just being disciplined about not putting things in the module if it doesn't have to be there?
Yeah, I think that's a great segue into actually talking about the ROP. And yes, I think it's has proved very beneficial, like coupling and cohesion. Everything that's good in software boils down to that, in my opinion. And these things, all of these steps are very cohesive. They do only their one thing. They're very loosely coupled. All they do is take this hash that's getting passed along the chain, destructure out and type check what they need, and then do their thing. So it's really, and the people who aren't Ruby programmers, like Vishal and Hunar and Go programmers that are coming into this, they like it because they're like, oh, there's not all this Ruby craziness and magic and things coming from everywhere. It's just code and functions. You agree, Vishal?
Oh, for sure. I think I've said this multiple times and I don't hesitate repeating it again. Don't kill me, but Ruby is a little bit crazy for someone who's just jumping into it. This kind of makes it more palatable for me to, I don't really need to know Rails. I can write if and for, I can do that. I'm decent enough programmer to write an if condition. With this, I can manage the Ruby on Rails code base. I don't have to interact with Rails much. I just need to know where the models are and I can write if and for, and I can get my work done. So that enables me to contribute to the project. But otherwise, if this pattern was not there, I'm being very honest, I wouldn't be able to contribute anything on the Rails side on remote development. But yeah, this pattern did help me to make some MRs. I wouldn't say they were very complicated, but definitely I don't have to depend on someone who knows Ruby on Rails to unblock me on these things. So I would say there's definitely benefit of this. And I'm a big proponent of it. Like I've said this to Chad multiple times as well. Thank you for doing this and making my life easier on this one.
Cool.
Yeah, can I piggyback on your sentiment, Vishal, of so having orbited contributed to our main project for a bit compared to this this approach, it's like the GitLab main project is a humongous Rails project, and everything probably has the stuff you end up touching probably includes dozens of mixins and concerns, and it's really hard to find where things are defined. That if you ever want to make a change, you kind of, as an engineer, you kind of have to be like a surgeon, where all the organs are all right next to each other. You kind of have to get in and out and make sure that everything else stays stable. Whereas this way, you have really good boxes around the responsibilities, so that you could be a little bit more like an engineer, thinking of ins and outs that aren't going to mix into some sort of organic soup. Yeah.
And it drastically reduces the context which I have to worry about. Like, okay, I'm in this file. I only have to worry about this particular sentiment, right? Like this logic, very small context, small pieces of isolated logic that I have to worry about. And I can then comprehensively think about all the test scenarios that could come out of these things. Like Chad would put it, coupling and cohesion, right?
Right, which you can
Loose
see
coupling,
here.
high cohesion.
For example, we've had to make many changes to like the tools component, how we inject that. Like this all flows down to controlling the Kubernetes on the workspace side, but you're only working in this file. Like, yeah, all of the stuff that's going on and the way we're building up these Kubernetes resources that we're building, this is your whole world when you need to change that. And the only dependencies you need to know is like what's getting passed in here. So going back to your question, Jesse, like, and it's a good segue into this pattern. Yes, with this, each of these only have one entry method. Like that's the way this result chain is designed. So if you go, so that leads us to the railway-oriented programming. Here in the menu, railway-oriented programming and the result class. So there's this presentation and video, which is really good. I highly recommend going through this and this. And these concepts are also, so this is all in F#, but it's very translatable. The result class that we have is essentially modeled directly after the Rust result class, which is a standard monad. You don't need to know what a monad is. It's not a burrito. It's just some code. And the API, the naming of everything, very inspired by Rust. And also this, I know Enrique has read this book, Domain Modeling Made Functional, which is a whole book that uses this approach as well as many others to say, how can I be very disciplined, domain driven in how I architect my code and think about designing it. So I'm just going to lean on his presentation and hit some of the high points to explain the concepts here. So happy path programming. Y'all can see this, right? It's big enough. PowerPoint's kind of weird formatting this. I don't know. I just downloaded it, but whatever. But here's an example. Really close to the thing we're looking at here, right? Like we get a request and we're going to do a bunch of stuff to it, and then eventually, validate it, build some stuff, and then eventually persist something to the database. So sort of same thing here. We got a request and we're going to do some stuff to it, validate it, maybe update it, send an email, and then return the results. So with imperative code, that's pretty simple. Like, okay, we're going to have some functions here that do this, call them, get some data, update the database, and then return it. So which is all fine and well when everything works. And in a in a functional language, this just looks like piping the output of one function to another. Cons from Haskell. It's probably the only thing I remember from the Haskell book. But what do you do if something goes wrong? Right? Lots of things could go wrong always. You know, the name's blank, email's not valid, user not found, database. So then in an imperative way, like, well, you have all of these checks. And so instead of those 6 clean lines, you have 18 ugly lines that are hard to reason about. They're coupled. How do you do that? So like in a non-functional way, it's like, okay, the happy path, everything goes through. But if something happens, like you exception driven logic, you throw an exception and then somewhere up here, you have to figure out how to handle that. So in a functional world, and with this railway oriented programming pattern, it looks like this. Happy path goes through. If anything happens here, you short circuit the rest of those, but still handle everything at the end. This talks about the result type and the monad, blah, blah, blah. But these pictures are what I was wanting to get to. So how can you write these things so that they're composable? So you write these steps that look like these, that are, and this is sort of all implemented automatically by the result pattern. So you can have a step and it could have a success or failure, and then you plug those together. And that's conceptually, if you're a visual person, how you should be thinking about this. And some of these cases, I'll go back to the code. You see some of these are and then, and some of them are map. And again, inspired by the REST API of its result type. The and then are things that could fail. So that means like, okay, if anything fails here, it's going to short circuit all the rest of this and not do anything. The maps are things that they don't have any failure scenario. They're taking your input, transforming it, maybe adding something to it, and returning your type, your return value. So like volume definer, tools component injector, those can't fail. And then obviously the creator is the last thing, and then it could fail. That's the basics of this pattern. The result type is here. Everything in it is documented. It's the one thing that lives under lib. So if anyone else wants to start using this pattern, they could start using it. And you can also compose these things. Like if we look at, so the last step here is creator. So in it, it's got its own little chain here, like all of the sub-steps for creating, like creating the personal access token, actually creating a workspace, which is one active record, creating the workspace variables, which are other active records. And you can see here where we're leaning into, you know, the way Rails works. Like the way Rails works at the very top, when you come into the controller and the request, a transaction is started, and then anything that happens there, if that transaction fails, everything's going to get rolled back and blow up. So we're sort of leaning into that here. We're saying, okay, if we're still doing this nice railway-oriented programming pattern, and each of these things could have their own failure modes with a particular message that is going to get, you know, turned into something useful to show, like variable, you know, duplicate record or some validation failed here. But we're raising the active record rollback, which causes this transaction we wrapped everything into rollback, which then causes everything else. It's atomic. It's all or nothing here. So this pattern is like how we can say, okay, we're doing multiple persistence things here, but they need to be atomic, all or everything, and we're leaning into transactionality and having this whole subchain, which is atomic. Does that make sense? what else? That's the crux of this. And you can dig into like how this is working under the covers, but the nice thing about it is like you really don't need to know. Like you're chaining this together, and I'm going to make a method that does make a class with one method and tie it together in this chain. Oh, the other thing I was going to say, so we recently did a settings module, which so like in GitLab, your settings can come from GitLab.yaml, like at the instance level. They could come from environment variables. They could come from, the one table with a big record that's got all of the settings in it, or each domain may have its own table that's got some settings in it. Point being, there's like all of these places you can have different settings, and we've actually documented this, how it works. So we wanted this algorithm. It's like, okay, we can get settings from all of these places. We want to have a standard way to get them. And there's this idea of precedence where it comes from settings, current settings, which is the GitLab YAML, or from the record, or from maybe cascading namespace settings, which is another way to get them. And then the very final one is like environment variable. Always wins. It's an easy way to roll things out. If you don't want to write a UI for a setting, let users override something, you can make it an environment variable and then backfill, wherever it makes sense, or write the UI or put the settings and the options in the sidebar, whatever you need. And we use this pattern here, and it worked out really well. One of the things that was really cool is like, initially I didn't have in my mind, right? Like I had the environment variables first, and I'm like, no, what makes the most sense is like these always win. And it's like they're only intended for early access when you don't have any other UI to set it or another means to set it, or if you want to like override it globally. It's like, oh, the whole instance level, I just, for testing and development or on-prem, whatever, I just want to set this thing in an environment variable, boom, set it. And I was able to, instead of, this being the first step here, right? I just moved it, the order of the chain, loose coupling and high cohesion. Like other than the test of this class itself, the main class, which says how everything is wired together, there were no other changes needed because this doesn't care anything about other than what's getting passed into it and what it depends on. It's cohesive and loosely coupled. So again, it's a different case of what Vishal was saying. You only need to worry about the one particular cohesive piece of logic you're currently working with and not care about much else. Let's see, a couple of other things. Our models, like we try to, like all of the business logic lives there, but some lives in the active record layer just because that's the place that makes sense. So obviously the associations, the validations, and the scopes. And like before save, a lifecycle hook, we use that one place. These little wrapper methods that are, massaging a little bit of the actual fields, returning some data. These make sense to live in the model. Like we could put these somewhere in the chain, but it's again, just why not lean into Rails idioms? Like if the model is a fine place for this, there's no reason not to put these things here. But like no actual business logic, like nothing like, whatever we're doing in here, the tools component injector. I think that went faster than I thought. I think that's about all I've got. We can open it up for questions. Like I said, I want to do further sessions maybe and dig into some of these in more detail, like the type safety and other stuff. But thoughts?
I have a quick question about result types. So I'm a big proponent of using result types rather than just throwing an exception that you don't know if it's going to get caught or how it's going to be handled. So I like being,
but like, that's the one final thing I wanted to cover. Like, and I even have the, he has in here, like, all the places you don't want to do this, like cases you don't want to do this. And we also have, I think, error handling, right? And this comes up a lot once you actually start digging into this. You trying to I can't find it now, but somewhere in here, like, you want to only catch errors that matter, that are useful to be handled through this chain. So an out of memory error, right? Or, you know, the database is down or something, there's no point in handling that. Just let it blow up right in the middle, bubble off the top of the Rails stack, blow up. And so it's not like we never allow exceptions to handle, but only we only want to handle the errors through the
yes,
business logic.
absolutely.
I'm not sure if Enrique had his hand up before you started, John. Can you let me know, Enrique?
Yeah.
Oh no, it was after John.
Okay, go ahead.
So John, if you want to complete some thought or ask another question.
Yeah, no. So my question was around, and I had put it in chat real fast, where it was around domain boundaries and sort of modeling your errors. Do you ever do something, because you were talking about happy path, where it's essentially like, hey, we're constantly chaining our happy path, and then if we had an error comes up, somewhere someone's going to eventually resolve that and say either I can recover this or not. And do you ever sort of define, here is our boundary errors that are ever going to cross that boundary, rather than so essentially catching your errors, but doing it in a functional way, and then returning a new domain error?
Most of this stuff is pretty organic. It's just like driven by whatever the requirements are. But like you can see here, that's what these particular things are. Like, I guess the determining factor is like, is it something useful? And these class names get automatically turned into a sentence and displayed to the user, either on the view UI or in the GraphQL error field. So, you know, that's why they read like a sentence: workspace create params validation failed. So maybe that's the answer to your question. It's like, if it's something useful that we want to bubble up to the user, yeah, then we do it. If it's something like the database blew up, they can't do anything about it anyway. We don't care. Boom.
Yeah.
We ran out of memory, like, just let that bubble up. Absolutely no reason to write a line of code to handle that in our business logic.
Cool, that makes sense. Yeah, I think I'm trying to implement something very similar in on editor extension side for Visual Studio, where instead of throwing exceptions, which are really dangerous in our environment, because actually a thrown exception that doesn't get caught will actually crash all of Visual Studio. So instead of throwing exceptions, we're essentially going, hey, result types everywhere. And we don't have a, go ahead.
You could just put a rescue around this whole thing, right? And then it's like, okay, nothing gets out of here. Like, if anything that's handling unexpected, I'm still going to handle it in some way that is safe for me.
Yeah. So you have so in my particular case, because it's this like plug-in architecture, you have these weird, you have like multiple entry points. So you don't have a great place to like a global error, catcher. So you'd have global error catchers at all your entry points, which is totally fine. But yeah, I've noticed things where it's like I end up having a domain that I'm working in, and certain exception types tend to bubble up past probably where they should. So I've ended up creating something where it's like I can essentially say, hey, map whatever, I'm about to leave a domain boundary, and I'll map whatever error I have into an error that I expect my callers to potentially be able to handle, so that they don't have to know about all of my error types. And I might have like an inner exception kind of deal too, whereas like if you needed more information, you can go look at that.
Yeah, the layer here, like, so that's the way we've abstracted this layer from the standard service layer.
Mm-hmm.
So we have this there. Yeah, the create service. So there's a standard service response object, which like the GraphQL API layer and the Grape REST API layer know how to handle and turn into, you know, useful error messages. So the abstraction layer we have is like, that's the whole point of this generate error message, which
Nice. Yeah.
creates this hash, not coupled to service response, because that's in the layer above, but the hash of all the things that need to go in it. And then that is turned into a service response object here. So that's how we loosely couple this, but still make the interface look like what the rest of the API layer expects.
Yeah.
I think to add to that too is there's always this tension of like when you're doing functional programming of keeping things decoupled, yet you are gonna run into aspects that are supposed to like touch everything of authentication and logging and error handling. And I would say like those are the cases. And in this situation is like there's this general utility that all of the little bits, it's okay for them to be dependent on, because you just can't escape the need for these aspects. And when you talk about like the extension architecture where you have multiple entry points, and they all kind of need to do this like similar error handling thing, it'd be really interesting to use like I think decorators or some other like aspect oriented programming to like just encapsulate that like common bit that everything needs to do. You know what I mean?
Yeah.
I know that Enrique, you had a question. We're running
Yeah, I
close.
want to make sure to get to Enrique.
Yeah, so one of the parts of your presentation that caught my attention was how we can mix the Rails-oriented programming with the hexagonal architecture. And I remember that usually one of the challenges with functional programming is how you can push away the, let's say like the infrastructure layer and inject those dependencies into functions, because like you don't have like the classes where you can say like, oh, I'm going to just like to have a constructor and I'm going to inject those dependencies and then I can use them in the business logic. Looking at your example in the code, I couldn't see how the functions that are composed using the monads, how are you injecting the active records and all of that?
Yeah, so let's just follow this example down. So like, here's the first place we see this, right? In the GraphQL example, we have a mutation, which, you know, this came from some GraphQL mutation that's submitted. And there's very, you know, no business logic here. We check the license, like we do authorization because it's standard to do it at this layer. But other than that, all we do is pull out the arguments, get the parameters, get the objects, and then create the service and inject. In this case, the only thing we needed was the current user, right? Because we're creating something. If we looked at update, for example, you know, it takes the user and then executes with the params and args. And at the service layer, again, like I said, this whole layer is probably going to go away because it doesn't serve any point. We could just as easily call this main directly from the GraphQL API. And so this kicks off the beginning of this ROP chain with the arguments it needs, inversion of control, whatever you call it. It's injecting these things. And then here, and this is important, like this knows nothing about it. And all of these other steps know nothing about what they do. It's only where we actually destructure out that we have a hard dependency on what's injected into this. Does that answer your question?
Yes, I just couldn't see where the dependencies were flowing, flowing from. Now it's evident, but it's like it is like embedded in the initial result object.
Right. So it's just this is exactly this picture here. The flow.
And each step of the ROP can add to that context, that value, the value thing that has been passed along in each steps of the ROP. That is basically a hash value, right? And each step of the ROP can keep adding to that hash, which can then get used in the next step of the ROP chain. So if,
Right.
let's say, if in step 1 of the chain, you found out the workspace for which this request is, you just add that workspace object to that hash and pass it along. 3 steps later, they need to find out the def file for the workspace, like a particular attribute of the workspace. You can just access that hash, extract the workspace from there, and just access the model directly from there. So that's how you also pass things along. It's not in the constructor, but just a simple hash that is being passed along in the entire chain, which you use wherever you want.
Yeah, where's an example?
Surprisingly, that sounds chaotic, but surprisingly, that works out quite well.
Yeah, like where can you see this?
I think the def file fetcher pre-flattened valid should process something. Def file fetcher should give you something. It gets the file from Gitly and puts it into the hash object.
Right. But the point being, like, you can mutate this single hash that's getting passed along the chain. And Dylan brought up the point, it's like, it's not a good idea to mutate your arguments. And yes, usually it's not. But in this particular case, because we have pure functions and we don't hang on to any state, right? It's not like we're ever gonna hang on to the current user, or in the case of the update, the params that we pass in and then like do something with them after that. It's not something we would ever do. So like we could try to enforce immutability and say like we're gonna deep dupe or deep clone everything, but then that has performance overhead implications for garbage collection and stuff like that. So it's like, no, it makes sense to just, modify things as they go along the chain. And because these are all pure functions, it's like, well, they feed into each other, and it's fine if they mutate it, because nothing else before it is ever going to care. We hold on to no state, and they're all class methods. They can't hold on to state. Okay, I think we're getting to the end. Does that sound good, Shakar?
Yeah, sounds great. No, thank you for this, Chad. This is superb. I'm sure all of us will learn quite a lot. And I look forward to more deep dives into this topic. So thank you.
Yeah, like Vishal said, I really like it, and it seems other people seem to too. It just makes things easier to reason about, because coupling and cohesion, everything boils down to that. Okay, thanks a lot.
Thank you.
Thanks, Chad.
Bye.
Thank you.